This may come to surprise for the whole science community because I think I may just have discovered the source to unlimited free energy. Come have a look.
Let me show you what I discovered. So when I take some regular household copper wires and start to build nice even circular coil from them, all while reminding myself that this has to be very evenly built and this is going to take a lot of time, patience and of course hot glue to accomplish this task. And when this is complete, I can attach a bulb holder to the coils, and when I attach a bulb to the holder, the bulb glows. And look, this bulb is not self-powered and this is actually being powered by the coil, because if I lift the coil, the bulb turns off. So the electricity must be coming through the coil and the ground. Just for your satisfaction, look at this. This is a heating wire from a heater attached to a bulb housing, and when I connect this to the holder and let it sit for a while, let me zoom a little bit to show you a bit clearer. This gets super hot and melts bulb's plastic housing. And this gets so hot that this even lights the paper on fire.
So let me tell you a secret.
Researchers propose that the pyramids constructed around the world are, in fact, power plants. This is based on our new knowledge that they, in fact, are designed to tap the resonant power of the Earth and then to distribute it around the world.
And guess what? The same kind of energy pocket lies just here in my lab, and all I need now is to make few of these coils and I can solve the world's energy problem. How cool is that?
Oh my God! Wow!
This is bullshit.
If you truly believed about the free energy part, then I'm really very sorry, because unfortunately there exists no such thing as free energy unless you plug your bulb to your neighbor's house and then your neighbor has to pay for the bill, but it will be free for you. Anyways, jokes aside, the thing you just saw was not fake but in fact 100% real, but the thing that was hidden was an induction stove below. It has some very hot metals below, which is a safety feature that turns the stove off if no utensils is placed over it. But see, the previous stunt was not fake and the bulb will still turn on when placed near the stove. And the bulb will stay on as long as the induction stove is on. So this is not the free energy but the wireless energy. And we should not be surprised that the same device that gives the wireless electricity also cooks our utensils, because after all this is an induction stove meant to cook food. But seeing that bulb glow in thin air, should I be worried about getting shocked while touching these bare metal utensils? And another mind-blowing thing is that even when I place a thin sheet of paper under the utensil will still heat up, and as you can see the water is still boiling, but the paper just does not burn. So you tell me, how does this even work? And where the hell is the heat even coming from? And another is why certain types of utensils work on the induction stove while the others don't. So today I will be explaining the science behind this technology and showing you how this works in action. So if you have ever been curious about the induction stove, then this is the video for you, and if you really stick to the end of this video, you will also get the opportunity to learn how wireless energy transfer works. And worry not, even if you are not from the science background, then still you can get all this stuff into your head. First, I will explain the wireless energy transfer part, because today in this modern world, every new flagship phone got the wireless charging capability. But before we move any further in the video, you answer my one question. If an induction cooker can transfer wireless energy, can your wireless charger cook your food? Let me know your thought in the comment and let's get started. Notice that I have a magnet whose one pole is colored. So if we apply electricity to the coils, the coil produces a magnetic field and the magnet jumps, because we know north pole of the magnet always wants to stick with the south pole of the another magnet and vice versa. An incredible thing is that if we change the polarity of voltage to the coil, the magnet also rotates from north pole to the south pole because of the changing magnetic field that we produced by switching the wire from positive to negative. So this effect was first observed by a Danish scientist named Hans Christian Oersted in 1820, and this effect was revolutionary because this was the first and most important discovery which led to the modernization of the production and distribution of the electricity as we know of today. Let's take a look inside this permanent magnet-based electric motor because just 10 years after the Oersted's groundbreaking discovery, scientist Michael Faraday made an exciting revolution that not only can an electric current produce a magnetic field, but a moving magnet can also generate electricity. Let's see how this principle comes to life. Opening this motor was pain in you know what, and a small mistake here can leave me with less than 10 finger counts. But for you, no risk is a big risk. This device has two key parts, a rotor with magnets attached and a stator with coils. The coil here is very similar to the coil I just made, but instead of the circular coil, it has a rectangular coil wound between these slots of the motor. When you rotate the magnet near the coil, electricity is generated in the output wires. And if you give the electricity to the wires, the magnet will spin. This is the wonder of electromagnetism. Look, you are here to learn about induction cooker, but you got lucky and you had an opportunity to dive into the internals of electric motors. The construction of a permanent magnet motor is really interesting, isn't it? And as if deassembling this motor wasn't challenging enough, now comes even the harder task of putting this back together again. Just try not to mess up, or I might have to start counting my fingers again. But anyway, once it's done, now for this demonstration, I'm attaching a small 12-volt light to the output wires of the motor. And when I spin the magnets by spinning the shaft of the main motor with the help of a hand roll, the LED glows. The faster the spin, the brighter the LED. This experiment showed that rotating magnets near the coil produce electricity. This electricity produced, however, is not direct current or DC, but alternating current or AC. You might have a question that what is AC? So this can be understood by the previous experiment where we switched the polarity of the coil to produce spinning magnets. But here, the same spinning magnets inside the motor produce the switching and the alternating electricity known as AC. So enough description. What I essentially want to explain is changing polarity in input power or providing alternating electricity to the coil causes the magnet or the magnetic field to spin. And we also saw that a spinning magnet causes the coil to generate alternating electricity. Therefore, in theory, by providing alternating electricity to one coil, we can create electricity in totally different coil. And this is called electromagnetic induction in terms of physics. However, this is just a theory. Let's try to see if this theory really works in real life. But to demonstrate this, I need another coil. And where can I get a similar type of coil? Yes, you guessed it correct, an induction stove.
Oh my god, there are alive cockroaches here.
I was planning to say that the first thing you will notice is the big circular coil, but damn these cockroaches. Back to the video. The first thing to do here is to remove the coil to prove my previous hypothesis of transferring electricity from one coil to another. The stove must have been a good place for these cockroaches, but from now they don't have to look for the places to sleep. They all will sleep in heaven. Here I got my coils and finally I have a pair of coils. I have connected the LED to the coil that I got from the induction stove and my homemade coil will be placed on top. Now when I connect and disconnect the battery from my homemade coil, the LED attached to the another coil below glows for a brief period of time. Also remember, the LED will not glow continuously if I fix the wire to the terminal, but only when I connect or disconnect the coil. This happens because Faraday said the electricity will be produced by the changing magnetic field, not the static magnetic field. That's why the magnets need to spin in the motor to produce electricity. The faster I can connect and disconnect, the brighter the LED becomes. And to clearly show you this, I am using an asymmetric metal piece attached to a handle that vibrates and touches the battery very fast. And when I slide the wire on that metal piece, the LED glows brighter and is noticeably stable, like the flickering is a bit less. So this is how the wireless energy transfer works. By the way, the same method is used to charge your phone wirelessly, and based on this exact same principle, all those big transformers are built. Now I hope you have clearly understood how wireless energy transfer was possible at the beginning of the video. And let's talk about the stove now. This coil has some ferrous metals below the coil to redirect the magnetic field upwards. And here is the board on which the coil was connected. By now, I think you might have already guessed what this board does. But if you still don't, then listen. Instead of me connecting and disconnecting the power manually, this circuit does that switching, and this does it very fast, upwards of 25,000 to 50,000 times a second. And that's how this is able to transmit that much power. About 2000 watt maximum to be exact. It is not that complicated. All this board is doing is taking power from the mains, changing polarity and switching the coil very fast to create strong and changing magnetic fields. Other than the circuit, there is a fan to cool the IGBT switch and the coil. Nothing much here. I forgot to mention, but the central white part of the coil has one temperature sensor, so when you cook something very hot in the stove, it detects that temperature and cuts off the power. We can now connect everything back to the main plate. There lies one chip that looks for the button presses and then tells the main board when to turn on and turn off the coil. This also regulates the heating by regulating the power given to the coil. On the top plate, we have some buttons and a small screen through which we can set various cooking power or temperature modes, and we can also set the timer and see the timing information and such. I hope by now you have completely understood the working of seemingly magic trick of getting wireless electricity. So let's now talk about how the heating happens. How does it heat up utensils, and why does it only heat up certain types of utensils? I know you surely have this question in mind, and this is the question I asked in the beginning of this video. Here you can see water is clearly boiling, and even when I put a paper below it, it still boils. But if I remove the pot and take the paper, there is no any burn marks in the paper, and the surface is cool enough to be touched by hand. So how does it work? My smart viewers might have already guessed that this is no ordinary stove, as the surface does not produce the heat as traditional stoves did. Here, the pot or utensil itself produces the heat. So let me explain. Here is the same previous coil, and when I connect the ends to some nickel wire taken from a room heater, you can guess the result. And yes, it gets super hot. I have showed the same thing in the beginning of the video by lighting a paper on fire.
Instead of this copper wire connecting to that small heating element at the end, imagine the whole coil was made out of that heating element and was connected to itself. Then what do you think will happen? So in that case, the electricity or the current will go round and round the coil, which is called eddy current, and the whole wire will get hot. You might have a question here that what is the heating element anyways, and why will this whole coil get hot when connected to itself? So basically, heating element is a wire with high resistance. So high resistance meaning the voltage tries to push current through the wire very hard, but the resistance does not let that current to pass through. So similar to when you rub your hand very fast and your hand gets hot, here due to electrons colliding and the electron has to go through the very narrow paths bouncing into various other atoms and electrons. So because of that friction in the electron flowing, the whole wire gets hot. And iron is a common and cheap material that is used to produce utensils, which also happens to have high resistance. This is the reason that you never see electrical cable made out of iron, because they produce too much heat when current is flowing through those cables. However, in cooking, we just need that heat. So it is advised to use the utensils that are made out of the iron or the steel alloys. I think I made it clear that the resistance is one of the reasons that the pot gets hot. Higher the resistance, higher the heat. Lower the resistance, lower the heat. This bowl works with induction and is made out of stainless steel. And I have another frying pan made out of aluminium, but because it has a steel plate stamped on the base, it also works with induction. However, if I add another aluminium pot, it doesn't work here. You might say it's because it has a smaller base, but mark my words, no matter how big your aluminium pot is, this is not going to work in this kind of induction stove. This is because aluminium or copper pots have very low resistance and they allow to pass the electrons easily, and the induction has to be very powerful to hit the aluminium or copper, because a lot of current has to be passing through the wires to produce the same level of heat. But it is not the case that the aluminium or the copper cannot be heated in an induction stove, because if I take this small foil of aluminium and put it on the induction stove, the foil gets super hot and melts instantly. This is because this thin sheet of aluminium has comparatively higher resistance than that of this pot made out of aluminium block. This clearly means that this stove is designed to work with the utensils made out of iron, steel, nickel, cobalt, or anything where you can stick a magnet through. But think twice. Why does the induction stove favor so much to those metals where you can stick a magnet? One answer is obviously that they have higher resistance and higher amount of heat is produced when current passes through them, but this is not the only answer. Iron is a ferromagnetic material, meaning there are tiny magnets arranged in random order inside the ferromagnetic substances such as iron, nickel and cobalt. And when they are brought near to a magnetic field, like a magnet or magnetic field, those randomly arranged magnet gets magnetized and arranged in a pattern and make ferromagnetic particles magnetic. So if you are confused by these technical terms, you might remember a nail hanging to another nail which is attached to a magnet. So this is the similar case here. And if we flip the magnetic poles here, the tiny magnets inside the nail also flip. And this flipping does not happen at free of cost. Organizing randomly arranged magnets requires some energy, and flipping them completely 180 degrees requires even more energy. So if we can do this flipping fast enough, that friction during that flipping causes friction big enough that the metal gets hot very fast. And to answer the question that I have asked in the beginning of the video, that should you be afraid while cooking on these type of bare metal utensils on the induction stove? The answer is quite simple. We should not be worried about getting shocked, because it is actually the current inside the pot that causes them to heat. So it has very low voltage, and because this is shock to itself, it almost has the zero voltage potential. So we should not be worried about getting shocked. And because this has one continuous loop on the base and we are not part of that loop, we won't get shocked. Also, you might have a question that how does this induction stove regulate power? And the answer is quite simple. It does that by controlling the power given to the coil. Let's suppose this is the coil in the induction stove. Then the induction stove can lower the voltage or the current given to this coil, which directly controls how much heat this utensil can produce. And for very low powers like 200 watt or 400 watt, the induction stove turns for a certain period of time and turns back on for a certain period of time. So the average will be 200 or 400 watt, but it will just stay on and stay off to control that heating. This was all about the induction stove. So if you found this video educational, please consider giving this video a like, share this video to your friends and subscribe this channel. I will see you in the next one. Bye bye.